Hi everyone. In this problem, the coin change, you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return fewest number of coins that you need to make up that amount. If that amount of money cannot be made by any combination of the coins, return -1. You may assume that you have infinite number of each kind of coin. So basically we have given the coins in the array format. Each index represents that denominations type. Here it is given there is a 1 rupee coins, 2 rupees coins and 5 rupees coins, and we can take infinite number such types. We need to form an amount 11. To make it, we can have different combinations. Suppose here it's showing we can have suppose one, like 10 1 rupee coins, 11 1 rupee coins can give 11 rupees, or 5 2 rupees coins, 10 and plus 1 rupee coin. But the condition is we can form the amount in any combination, but we need to first identify the less coins, the less number of coins. Suppose if we take here 5, the largest coin 5 5, then and 1, we can get the 11. So basically this is the intuition. If we try to solve it by iteration, the idea is it is an greedy approach. So first we will sort the array. Like first we will take the, since we want a small count of the coins, so we will first sort the array. We'll make it large to small, like we will sort it, and the count is initially 0. Then what we'll do, after sorting, it is small to big. In the reverse, that is I is coins dot length -1. In the from the last larger value to smaller value, we will keep take that amount. Suppose if the amount is greater than my if the coin value is greater than, then we'll just reduce the amount by that coin and coin plus plus. Whenever they, if the amount becomes 0, we will break it, and we'll just check if the amount is 0, or if it is not becoming, then we'll return -1. So here the while condition will keep check to make it breaking the amount from the larger value. But the thing is, this greedy approach can be wrong. Basically, this is an optimized problem. There can be many feasible solutions, but we want one most optimal solution. Like they said, we want to want uh, we want less number of coins. This is most optimized one they are expecting. So for that we can use the greedy approach, but the greedy can be wrong. Greedy approach cannot be right always. If we run this code, it will run successfully, but when we submit the code, it will go wrong answer. So here if you take this example, first we will sort the array. Like we'll try to take larger values first, for more optimized way, less number of coins. So for the amount 6, you can first take the 4, then amount to become 2. So then you can't divide it by 3, right? So you will go to 1. So you need one 4 rupee coin and two 1 rupee coin, that means 3. But try to understand, if you skip the 4, and you can with the 2 3 rupees coins, you can make the 6. So this is where greedy approach can be failed. So since we can't solve this problem by greedy approach, let us try to solve this problem by backtracking. How backtracking means, since we can take here infinite number of the coins, so we can take we will try to take the coins in multiple possibilities, like all the possibilities. Since we can take, suppose we can take as many 1 rupee coins, then we can take as many 2 rupees coins, then 5 rupee coins, and we can take as many 5 rupees coins and 2 rupees, again 1 rupee, and 4 rupees coins, like that. We can take like this combinations, whatever possible. We can take like as so many combinations until the amount become 0. So until amount becomes 0, we'll keep taking the coins, and we will keep counting plus plus plus. And also we'll check whenever the amount, suppose if the amount become less than 0 also, we will stop. So these are the base conditions. So so through backtracking, we will do all these steps. First, for example, the first backtracking, the amount is here 11. So first, if you take the 1 rupee coin, and you can again check for whether I can take 1 rupee coin again, 2 rupees coin again, 5 rupees coin again, like again. If you want to take the 1 rupee coin again, you can again check for, again I need to take 1 rupee coin or 2 rupees or 5 rupees coin, again check for 1 rupee coin. So if you keep taking this, so then you will stop when your amount becomes 0. Suppose at the beginning, once you take the 1 rupee coin, the amount become here you took, right? So here the backtracking of it will become 10, and again if you go down, the backtracking of it will come 9. Or if you don't take this one, and if you take the 2, so here the amount will become the b of like 8. Or if you instead of 5, instead of 2, if you take the combination 1 rupee and 1 rupee, after that 5 rupees, then up to here it is 2 rupees, right? Then again 5 rupees if you remove, then it is 5 rupees left. So like that. So as we know already, answer it is 5 plus 5 plus 1 combination. So all these among combinations, the perfect combination is, suppose if you take the first 5 rupees coins, again you can have the choice where I can take 1 rupee coin, 2 rupees coin, or 5 rupees coin. If you take again 1 rupee coin, you can go ahead. But it's so at one possibility, again we can take a 5 rupees coin. So here the amount is starting 11. Once you take the 5, so here the amount become 6. And then after again you took the 5 rupees coin, the amount become 1. So so then the best possibility is to take the 1 rupee coin. So at this point the amount becomes 0. So these are our base conditions. The base condition is the amount becomes 0, no more coins are needed. So whenever the amount becomes 0, we will return the 0. And the other conditions are, suppose if you take the 2, the amount will become minus. So whenever the remaining amount become minus, we will just return the maximum value. Why maximum value? Because since we want the minimum amount of coins, so that's what we'll write here. So this is like functions. There is a loop. So the loop like n size loop times will do the recursions. So that many times, suppose 1 to 5, right? So depends on the length of the array. 1 again that many times, again each again that many times. Or if you take 2, uh, again for 2 we can take, suppose you can take 1, or you can take 2 rupee coin. Again you can go and take 1 rupee 2 rupees coin, or you can take 1 rupee coin. Or you can take 2 rupees coin, then you can take 5 rupees coin, again take. So that like you will go like deep. Every time you're going down, you will call that recursion function inside it. So that's how it works. So you will just traverse the coins, like you will take every time each combination among. Again you will try different combinations. For that you will backtracking the same thing. So they, but here you will do remaining amount minus coin, because you will reduce the amount. Once you take such particular coin, you will reduce the amount. So whenever that amount become this 0 or negative, we saw that conditions. Now there is one more conditions, like once you go very deep, suppose you took like Suppose you took first 1 rupee coin and then again 1 rupee coin and 1 rupee coin, like 11 times you took 1 rupee coin, so your the coins become 11. So you can say the result become 0, right? So at that moment the minimum coins is equal to math dot min of you can take the because 1 plus result will return 0. So 0 plus 1, that is 1. It will keep adding. But if you take 1 rupee coins, it will come the input as 11, the longest. But when you observe, suppose if you take the best condition is, if suppose if you took 5 rupee coin, then 5 rupees coins, again 1 rupee coin, the size, the coins number is 3 now. So that it will just check every time whatever the minimum coins. That's why math dot min of minimum coins and 1 plus result previous values. It will just we keep tracking, right there. It will just compare, and every time we will just update the whatever in which possible combination we are getting that less number of coins we'll take here. And then at the end we will return the minimum number of coins. It looks like this. Suppose we have the this combination of the coins 1 to 5. We want the amount as 11. So first you can take 1 rupee coin, again take the 1 rupee coin, again take the 1 rupee coin, again take the 1 rupee coin, and keep on take like 11 times. Though, so when it becomes 0, it will return plus 1, again plus 1, again plus 1. But the catch is it won't stop here. One after at the end, whenever it becomes 0, it will go, because inside the loop we are doing the recursions that many times. So again it will check for the 2. So it is not possible, it will become minus. So it will come the best answer it will take again 5. So like that it will go. Or I will tell you the condition like here. Suppose you took the 5 rupee coin, then amount become suppose if the amount is 11, you took the 5 rupee coin, the amount become 6, and again you took the 5 rupee coin, the amount become 1. Then you have 1 2 5. The best thing is again take the 1, so it will become 0. So here the will return plus 1 plus 1 and plus 1. Suppose previously already the value is here, the returning value is 11, though it will just check that minimum coins is equal to math dot mean of 1 plus this result and comma previous value. So that it will just update whatever the lowest value up to the track. The problem here is the backtracking is very exhaustive, and here it is like the time complexity is very high, because every possibilities we are checking, we are considering. So it is like you try to run this code, it will run for the smaller constraints input. But when you run for the larger input, uh, like here the coins dot length is 12. So that many times it that many times if you need to go, then it will show time limit existed. So for that, what we need to do now, this is a code for the backtracking, where we will check for all the possibilities that you can check. These are the base conditions, and here inside the loop, every time we are calling again the all the possibilities of the coins, that particular set. But the time complexity is very high, it's very exhaustive. So we will just convert this backtracking to dynamic programming through we will observe that overlapping sub problems, and then we'll do memorization, and this is called top down approach. And the instead of backtracking, try to understand the dynamic programming. But the dynamic programming comes from the backtracking only. In the same backtracking code, like it is the same base conditions, and it is the same the main core logic, the recursions part. Here we will try to just try to observe like whenever there is an overlapping subproblems, we will do memorization. Suppose we have this 1 comma 2 comma 5. So we are calling this recursive recursive rate every time. So here the dp of amount is 11. So when you take this amount, the dp of suppose this is amount, the dp of the amount is 10. And when you take the again 1, the dp of amount become 9. And so and if again when you take the 1 rupee coin, and dp of the amount become 8, and so on, the dp of amount becomes 0. Whenever it becomes 0, it will return a plus 1 to the this previous function. So again, whenever you try to check again freshly, when you took the starting 2 rupees coin, starting it is a dp of 11 only, and it will become dp of 9. Again suppose if you now if you take the again 1 to 5 possible combinations, if you take the 1, it will become dp of 8. Again, if you take the 1 rupee coin, suppose if you take the 2 rupees coins, it will become dp of 6. But if you observe here, uh, let us try to understand this. Suppose if you take the 5, it will become dp of 6. Again, if you take 1 rupee coin, because again you can take 1 to 5 whatever coin you want, if you can take, suppose if you take 1 rupee coin, it will become dp of 5. The thing is already here if you observe the dp of 8, it's already calculated. The dp of 6 also, if you keep go here, it will be already calculated, because in the recursive calls, the main dp of that 11 amount will be called again every time you are putting in the loop. So whether you take 1 rupee coin or 2 rupees coin or 5 rupees coin, for every of these things you will call again the function, like again 1 2 5, again 1 2 5, again 1 2 5. So what happens is, at the beginning itself you will calculate all dp of 10, what is the result, dp of 9, what is the best possible result, dp of 8, and dp of then if you go like a dp of then 6, dp of 5, dp of 4, dp of 3, dp of 1, because the starting element is 1. So first it will, so when it will become the at the end 1 to 5, uh, you will go to, you will keep check for the 2 value. So that's how the overall the core logic is the amount minus the coins of high. This value is only varying, that part is already we calculate. So this is sub problem, the sub problem again we are going to calculate here. So that's why like we discussed in the Fibonacci series also. So actually we using this is called top down approach. When you use memorization, it will increase the space complexity, but the fact is we can decrease the time complexity. So we'll keep one memorization, one array, and we'll store that that 0 to that length. And whenever we for the first time we solved it, we'll store into it. And if we encounter again, we'll just check whether it's already solved or not. Initially we'll keep take -1, we will check whether it's already solved or not. If it's already solved, we did not solve again. So that dynamic programming, this is a top down approach. So we took the memorization array, and then we'll fill everything is -1. And now we'll call this function, and this is base condition is same if the amount is less than 0 or if it is equal to 0. But here the thing is, if the if suppose if you already stored some results before, we can directly use that. Or else what we do, we'll go down. So you can see if the memo of remaining amount is not equals to -1, something if you already calculated, then it will return the result. Suppose dp of 5 is already calculated, we can we don't go again. But if it is not calculated, we'll go down and we'll call that recursive calls for coin of coins, and result is equal to backdrop of coins, remaining amount of coin. So if you observe, this is only the variable is changing. That's how. So if the result is not equal to integer max value, then we'll keep update the things like we discussed this logic. And here once we got that something result, whatever result, we'll keep that into the in the array. Here we'll keep the store the current remaining amount of whatever that pos, suppose it is uh dp of 5 or dp of 10, for which combination we'll put. So at the last, because first it is a parent call, and will go all the child calls keep. at the start, at the last, once we done the starting parent itself, and then we'll return the whatever the minimum coins. Now when we run this code, it will be submitted successfully. We won't get any errors because we reduce the time complexity here.